Well, day 3, here we are. Alrighty. So, here we are for Honors Physics, and this is just a daily catch-up, live stream, check-in, see how you're doing, recap of what was going on today. Now, the way I set up this week was basically there's not really any daily assignments necessarily, because I wanted to give you just the opportunity to sort of make your own time when you get to do stuff. You know, you could do physics one day, English another day, whatever, worked for you. So me saying like, this is, what we did today, it's just kind of like the general idea. So like, for example, not for example, but in our case, first of all, I'll talk about that in a second. I mean, I don't even know if I talked about that yesterday. I feel like I might have, but for example, today, I'm going to talk about this because I talked about assignment number 4 yesterday. So I'm just going in order. Tomorrow I'll talk about assignment number 6. And the reason I did that is because assignment 1, I talked about it in class on Monday when we actually saw each other last, even though it seems like forever ago. And yeah, so that's about where we're at. That's how it was structured. Just, here's everything. Do it when you get to it. Okay, but definitely do it. So I sent out that clarification yesterday. I'll be honest, before that, I wasn't super clear on it. So I was going by I am going by what the superintendent says, because that's really who runs our school, is the superintendent, Dr. Guzman. And so anyway, that's why I sent that clarification out yesterday. And also clarification is, if you haven't yet, make sure you complete that summative lab report. You'll see that I started putting things in hack. I haven't started really putting in grades yet because, like I said, it wasn't necessarily a daily thing, and I think I'll start putting in actual grades tomorrow. But the grade book is ready to go. I'm just going to start putting in things tomorrow. Okay, so I've got the spots for them. Just complete it tomorrow, and I'll get to that. So I saw some of you guys already turned in the summative lab report. Make sure your name is on it if your team did it. And if it doesn't look happy, I will just try to make sure it's done. If it doesn't look good, then you'll just have to do that part over again. But hopefully you don't waste my time and your time by turning in something that's incomplete. I'd rather you turn it in late and good and finished than turning it in for tomorrow because it says it's due tomorrow. Okay, so this has been a very, very, very strange and unusual and unique several days. So if it's not done tomorrow, I completely understand. Just get it done when you can. All right. So that said, it's always open for questions. Let me just see how our live stream is doing the health-wise. We got a green light, so it's looking good. Today I'm mostly focusing, but I was able to wrap up the other non-honors, the regular physics, pretty early. So I actually just divide the stream into 2. So after today, I'll send a link I'll link this part to Thursday, because today is Thursday. And all right, so let's get to voltage. I already made a video on how to solve for voltage. Okay, so if you haven't watched that video, then do so in the next little bit. You can always ask me questions later via Remind, but watch that video. I purposely made it so that I don't have to spend a lot of time on this recap, because the recap is just a recap. I don't, it's not like I'm going to get in front of the class and teach right now. I will explain things and answer questions, but that's not what I intend for this. But basically though, where is it? There it is. So what I would do is, and I should talk about that in a second. You can write direct. I think you had to save a copy yourself. So save a copy, and then you can write directly on this. Now, what I like to do sometimes, because Word is kind of finicky when it comes to using a stylus to write on it, is print it. And not print it to paper. We could print to paper, that's fine. But print it and print it to OneNote. And OneNote is really good about like writing on writing on it. So it's fine if you do it on Word. It's just sometimes Word misbehaves and it'll take forever to save it. And the fourth question, yeah. And yeah. So I will do fourth question. So anyway, that's what I would do. So I'm going to just make a little, I gotta look over here when I do it. I'm just gonna highlight that. Okay. I'll throw that up on maybe not. Oh, there we go. All right, so now I can do this. All right, so number 4. Thanks for asking a direct question, Rachel. Let's just get right to the point here then. Red. Well, whatever, it's red, I don't care. Yeah, you know what, I do care. Let's change that to something else. Hey, Aiden, how are you? How are you? Rachel, before I get going on this, while I'm changing the color, I really wonder what kind of day it is today. Because sometimes I wonder, days kind of blend together now. Good. Thanks, Aiden. All right. Oh, good. Thank you, Rachel. It is, isn't it, though? It really is. Overall, no complaints. Alrighty, so the total voltage here is 72, and I could tell already I'm going to need my calculator out for this. So I'm going to get out my TI-83 calculator. I think I'm going to need my calculator. I guess I'm just assuming. So the total is 72 volts. That means everything needs to add up to 72, but it doesn't have to. It's not going to add up in the way you might think it's going to add up. In that you don't just take all the numbers and add them up to 72. Think of 72 as the high voltage, and so on well, I'll just say on one side it's going to be 72. So just to make it just to kind of whatever, we'll just pick a side. So let's just say that this is going to be our 72 side. It's going to have 72 volts, and this is going to be our 0 volts. Okay, so what's happening is the battery is pressurizing, it's squishing the electrons together in a way that they're repelling each other, so they have a certain amount of energy. And that energy, that difference between the one side and the other, where they're not squished together down on the positive side to where they are squished together on the negative side, that difference is what we call the potential, the electric potential difference, or voltage. And so on the one side it's 0, on the other side it's 72. Now, why do I mention that? Well, because that's what voltage is. And so what happens is, over on this part, we have 72, we have a certain amount of energy. And if you compare the amount of energy from up here to the amount of energy down here, the energy difference is 72, what we call 72 volts. Okay. So between here, the top part, and the bottom part, that voltage has to drop from 72 down to 0. And it does that in these little increments of steps. Now, it's different from flow. It's different from the current, in that current is the actual physical flowing or movement of electrons. Okay, like you could actually not see, but you can envision the electrons moving like those little blue dots in the simulation. Voltage is different. Voltage is just a measurement of the pressure on one side compared to the pressure on the other side. All right, and that's what we're doing here. So when I say the voltage here is 36 volts, what that's saying is it starts at 72 volts on one side, and we lose 36 volts on the other side. So in other words, it's going to drop down 72 minus 36. It's going to 36, right? I didn't know that. It'll comparatively drop down to 36 volts. It loses 36 volts. So you could almost say it's a negative 36 volts from there to there. Okay. So now for this whole part, we have 36 volts of energy, electrical energy. So, and I draw this because remember we have, it's like you're on the top floor of the school, 4th floor, and there's a couple stairwells. There's a stairwell. So you go down the stairs. Okay. You start on the 4th floor. Now you're down to the 3rd floor. And on the 3rd floor, there's all sorts of stairwells you could take down to the 2nd floor. But no matter where you go in the hallway, you're on the 3rd floor. And that's what's going on here, is no matter where you're at, no matter where you're at in this wire, you're at 36 volts. okay? Because you already went down 36. You started at 72, you went down 36. Now you're at 36. You're at level 36, we'll call it, okay? Now you get to this part, and this is what we call parallel, okay? It's like having two stairwells to choose from. And you could go down this stairwell, or you can go down this stairwell. You cannot go down both. And according to this, we know that when you go down this stairwell, you're going to lose 20 more volts. Well, guess what? If you go down this stairwell, you're also going to lose 20 volts because it's ending up at the same floor, the same energy level down here. Okay, no matter which way you go, you're going to end up at the same energy level. So we know that this is 20 volts. Okay, so now 36 minus 20 is going to leave us down to 16 volts is left over. Okay, so we started at 72, we lost 36, we went down one of two stairs. We didn't go down both. One of either one resistor. Either way we went down, we lost 20. Because they're in parallel with each other. So now what's left over is 16 volts. So what that means is that we're at floor 16 right now, and where do we got to get down to? Well, we got to get down to 0 because there's no more volts to go. There's no more resistors to go. And so what that means is that we go from here to here, or from here to here. Either way, how far are we going to drop? We're going to have to drop 16 volts either way, not 8 and 8. Okay, it's not halfway. You don't split it up that way. This is this is voltage, not current. And so now now you're back down to 0. Okay, so when I say the voltage has to add up to 72, you got to like look at parallels as acting as one energy level drop. Okay. We drop down, we start at 72, we drop down 36, we lose 36 volts, and then we lose 20, and we could take either path to lose that 20, and then we lose 16 more, and we could take either path to lose that 16 more. All right? Does that help, Rachel? Does that explain it? Hope I went over the right one. All right. So that's that one. What did I miss? I just explained number 4, Angelina. That's it. Awesome, Rachel. I'm glad. So I just explained number 4. So definitely worth watching again because I hopefully explained it in a way that makes sense. Okay, so that is definitely going to be worthwhile because understanding voltage, it's not something that you run across before. It's a different way of thinking. Okay, volts was like a label for a battery. What's the voltage? Okay, but knowing what that means, that's what this is all about. Okay, anything else I could do? I'm going to keep those for now. Okay, so all the rest are, like we start out just as parallel, or I'm just a series, and we have a couple series in parallel. Number 4 is just a parallel, and then it gets a little more complicated. As you can see, I cobbled these together from other things. Okay, so I'll come back to that if I need to, but here's the key, obviously, right there. And okay, so if there's any other questions on that practice, the voltage one, practice number 3, I will definitely answer them. But I will point out something. Did I say it in a remind? I think I said it in a remind. Is all these practices, I do want to give you credit for them. So when you get to the actual assignment in Google Classroom, either attach the file that you wrote on, or somehow take a picture of it and attach the picture of your work. That way I could give you some credit. It'll be formative credit. So if you don't get it in, it's not going to hurt your grade at all. But if you do it, then turn it into me and I'll get you your credit. I'll get you your, some reward for doing it, a reward besides, the knowledge of it. Okay. And being able to do it. Looking ahead, Well, looking slightly behind us, do you want us to take a picture of every practice? The ones, so like all these corresponds to the different assignments in the Google Classroom, right? So if hey Miguel, what's up? Oh, you guys are both here together, so awesome. So if I go to like Google Classroom and I go to like, for example, period 2, the first one, and I go to classwork. So these are the 6 assignments. So all these, to answer your question, Ellie, these 6 assignments right here corresponds to, I guess I just minimize that, correspond to these 6 assignments here. So yeah, I mean, like I said, if you want to turn it in there, you can. Dunk. So if you would like to get the credit for it, you can. All right. I'm not going to require turning in the formative stuff. I'll be not lenient. I'm going to be very flexible with that kind of stuff. Okay. But obviously try it and do it because it's brand new stuff. So yeah, turn it in. So because you did, the first practice was finding current in a circuit. All right. Then we're just doing the voltage in a circuit. And of course, tomorrow then the next assignment will be finding resistance in a circuit. So that will be covering all of V, I, and R, which is the Ohm's law stuff. And I already made a video on how to solve for resistance. Once again, there's a process. There's things that, series circuits are a little bit different than parallel circuits. And yeah, there's 2 sides. Side A is going to be, well, let's just put it this way. Side B will be a little bit more challenging than side A, but it'll be because side A is starting you out with either completely series or completely parallel. Side B will start to mix it up and give you more complex circuits. And all I'll say about for side B right now is if you have a complex circuit, just work your way from the inside out. Okay, I'll probably end up explaining it a little bit more in tomorrow's live stream. Okay, I don't want to get to that right now though. It's for tomorrow. All right, I don't know why I'm leaning so much. I think sitting down for so long. Let's see. I think that about does it. I feel like there might have been something else I wanted to mention, but that's it. I mentioned the summative lab report. I mentioned grades. Oh, next week, spring break. Right now, as of this moment, we have not been, we are scheduled to come back after spring break. However, I am anticipating that we won't, based on what other states are doing and what has been hinted at by the governor and other people. So it's nothing official yet, and it's all subject to change. If there's anything I hope you guys are coming away with is that the situation is very fluid and subject to change. So if we don't come back after spring break, then we will continue. I'll probably get a different structure. I know, right? We all will, Angelina. But if we don't come back, I'll have a slightly different structure because I will do a more day-by-day type of thing, and I'll just sort of do what I did in class, where for some reason you can't get it done that particular day, then we'll, I'll let you turn it in late. No, I don't. You guys are awesome. I don't want to stay home either. This is not what we were meant to do. It's like, it's weird. You can't even stay. It's yeah, I get you. We're all like that. On the other hand, I understand why they're doing it because of the whole flattening the curve and making sure that if you think about it, we got 150,000 people in Joliet by itself, not counting the surrounding cities and towns. And this virus hospitalizes a good 10 to 20% of the people that get it. So if you take 15,000 people, 10% of 150,000, 15,000 people going to Silver Cross and St. Joe's, And that's just Joliet. That's not counting Lockport. That's not counting Elwood. All the other towns around us, Crest Hill. You can understand why we need to get this under control, and it needs to stop. 15,000 people. They wouldn't be able to be in the hallways at the hospitals. So yeah. So nobody wants to stay inside locked up like this, but we have to. It really is for the best, and it's not forever. It won't be forever. We're going to look back on this time and to be able to talk about it, hopefully mostly pleasantly. And, but maybe not. But we'll be able to look back at this time in the future. This is not going to go on forever. So we will get out. We will get back to regular business as usual. There'll be some changes, I'm sure, but we'll be back. So this isn't forever. All right. All right. That said, are there any other questions about physics or anything I guess I can answer? We'll make the best of the situation, right? So, yep. All right. Well, you guys take care of yourselves and stay home. I know we're about to all lose our minds, but we can't go anywhere. We don't want to risk spreading this. I know we all feel like we're the exception. We have a tendency to feel like we're the exception. And I could go somewhere, but we can't. We need to all do this together. Otherwise, it's going to keep spreading. There's enough people out there that aren't taking this seriously and making this drag on. So, but yeah, do this tomorrow again. And let me know if you have questions. Hit me up on Remind or email if you have any other questions. All right. All right. I don't know. Basically done talking about physics, so there's nothing else. You guys have a wonderful afternoon. All right. Take care.